Can you hear me, everyone? Okay, three of you here. Let us wait for this. See, don't worry. The faculty, Niranjan sir, will be taking your classes. I told you there is some problems we are facing in technical level, as well as the cyclone is coming on. So electricity is gone in most of the places. I have some inverter, so I am taking the class for the moment. So hopefully you can see, as sir told me to talk to you about the quantum numbers from the atomic structure. I will be going through this chapter only then, and maybe you have a little bit better idea about the quantum number. Okay, but still, before we start, let me wait for few seconds, for 1-2 minutes, so that others can join, because there is a little bit change happened in our app. So students and faculties both are having some problems, because we changed it in the morning only, just before the classes. Okay, only one student is there right now. Three, four students are here. Where are the others? Okay, Inmaz, what you are saying, that there is an option to join the classes. See, you are going, when you are going for the classes in the normal join, in the batches, you will be automatically join. Okay, so that's few changes we are doing. You can. Yes, lots of students are there. Okay, I'm telling you. Yes. Okay, as you people are coming one by one in the classes, so let me start the class. Okay, so Nilanjan sir will be taking the classes. Again, I am telling the same thing, but there are some few problems we are facing for the cyclone and everything. Electricity is going up and down everywhere. So Nilanjan sir requested me to go through this portion at least for you, that is quantum number from the atomic structure chapter. It's the othermost chapters. Hopefully sir have went through something about this chapter. There shouldn't be any problem for you. Let me check some things. Okay. can see a little bit better. Okay, yes. Okay, so should I start or should I wait a little bit longer? Okay, there is only one student I am looking at. So anyway, so let's start. That what is quantum number? See, as teachers maybe have told you that there is a quantum mechanical model. Okay, what is a quantum mechanical model of a atomic structure? See, till Bohr model, Bohr has said that there are lots of different things about what is. Let me go through this. These kind of things, okay, that hydrogen, what is hydrogen models and what are not, these are the things that Bohr have told us. But the problem is, whatever Bohr said, there are little bit of errors. To counteract that, there is like Heisenberg uncertainty principle, as well as the dual natures of matter, going through them. So we came through quantum mechanical model of the atom. So what is this quantum mechanical model of an atom? See, quantum mechanical model of an atom is nothing but a model that is invented, or not actually invented, it's given, it's requested or calculated by 2 or 3 different scientists, mostly that we know of the Summerfield and Bohr model. The latest model is known as Summerfield and Bohr model, and that model is calculated from this equation. Okay, so this one, and this one is developed by Erwin Schrödinger's. So here I am not going in the depth. There is no meaning of going through in the depth about what is Schrödinger's equation, how it is going through, what is happened. There is no meaning, and neither I am going to calculate or give you this type of answer right now. But let me tell you few things about Schrödinger's equation. So Schrödinger's problem. See, there you can see this psi. Okay, this psi is called a probability, a wave function. Okay, and psi square is called a probability factor. The probability factor of what? Probability factor of a electron. That's what it is saying. So probability factor of electron, where? Probability factor of electron from the nucleus to a distance. Okay, means where the probability of electron is higher or lower, that you can get from this model or from this atomic model. Okay, this is called a quantum mechanical model of an atom. So this is the word, what is nodal points and planes. I am not going inside the whole detail, as I hopefully professor has told you. Nodal point means where the probability is 0. Okay, where the probability of electron is 0. Till now we are thinking about that electron is moving in a circular path or somewhere else, and there is exact energy. But as Heisenberg said, it's impossible for us to anyway calculate that exact time and position for them. Okay, so what they said, that there is a probability, we can calculate only the probability of electron at any point. So where there is the 0 probability, they are called nodal. So these nodal point are spaces between actually 2 different orbits. Okay, then comes around the quantum number. So what is this quantum number? Quantum number is the way we are expressing different orbits or the electrons identity. That means where the electrons are. hopefully you are getting if you have any problem, please ask the question in the chat. I am just go through a breeze through of the classes. I am not going to go through in the lots of details and everything. I will upload the video also, don't worry anyone. So please tell me if you will facing any problem. So the quantum number is nothing but a pin number of electron. Okay, pin number, where we use the pin number not only in our mobile phones, we also use in our postal code. Okay, pin means basically it's address where the electron is. So from the quantum number you can actually say exactly the position of, not exactly where it is traveling, but where it is, their energy levels can be calculated, and they have lots of different shells and sub shells, and which way they are going, how we are going to know which electron is coming from where, that can be calculated from their quantum number. So quantum number is something like that, your address, like what is your country, it's India. What is your state, it's Nagaland or West Bengal. So this is the number 2. What is your district, it's maybe Dimapur or it's maybe Kolkata. What is your city, it is the Dimapur city. What is your locality, same thing is quantum number. So there is 3-4 type of quantum number that we know of in our academy. What are those? See, something like that. So this is the shell and subshells things. So first thing is number n. Okay, n is the primary quantum number, you can say. This is the basic quantum number, like it's the country or your state. You need to be the basic thing. The first thing you need to know which country you are from. That is shell. Okay, it is always denoted as n. Then comes different subshells like SPDF. SPDF is actually how you can, okay, you want to go for the previous slide, no problem. This one, right? You can see. Oh, you want to copy the formula. See, you can find it in the, let me check. Okay, so this you can find in your books. There will be no question coming from here, so don't worry about these things. But let me tell you, there is no problem. You, okay, nodal points is, this is the nodal points. Okay, nodal points means where there is the electron's probability is 0. They are called nodal points. It's nothing impressive or something like that. It's where the probability of electron is 0. It's in quantum mechanical model, there is no possibility anywhere you can exactly calculate any kind of probability, any place or any possibility of their speed and their position to calculate. It's not possible. So what we do, we try to get something like that electron cloud. Okay, so we call it electron cloud. Very simple things. And let us start for the next one. Don't have to worry, don't need to calculate this. I will upload this in the state. Okay, I will upload these documents. You can go through for this. Don't worry. I will upload today only. So these are, the first thing is the shell, this N. Okay, then the L is the subshells, SPDF. What is this SPDF? SPDFs are how they look like, the subshells. Shell is the N, okay, that KLMNP. Subshells are the smaller rod, okay, the lanes, bi-lanes of a bigger rod, and how they look like. So SPDF actually how they look like, they are how they look like. Okay, it doesn't means it's a different or it's others or not, nothing like that. How they simply look like. What is their like S, it's a circle. Okay, P, it's a dumbbell. D, it's a double dumbbell. I will show you those things. Okay, how they look like. And lastly M is their direction. Direction means which way they are leaning on. So many people get confused about this. Try to understand this. After this, there is this magnetic quantum number. Okay, magnetic quantum number means how many types of S are there. There is only one type of S. don't ever think that P has 6 electron or 3 boxes. It's not right. Actually, there are 3 types of P. They are denoted as +1, 0 and -1. 3 types of P means 3 way they are leaning. They have 3 direction. Okay, X, Y and Z. Same way there is 5 type of D, and lastly there is a 7 type of F. That is the way you actually need to understand. Never ever assume that SPDF are simply is saying they are coming together, so there is 5 electrons or 10 electrons is D. That's not true. There is actually only 2 electron can be in a single subshell. They are said +½ and -½ okay. What you can say, there is 5 type of D, okay, and one single D can accommodate 2 electron, +½ and -½ This is called spin electron, this +½ and -½ Well, I will explain this to you later on. Let's go for the next slide. Okay, there are few things we have given. What is principal quantum number? It is the main shell or the orbits, that K, L, M and P. So principal quantum number, from principal quantum number you can calculate how many maximum electron is there. The formula is 2n square. You can find it in your book, just 2n square. Okay, lastly is azimuthal or angular quantum number. I just told you, it represents the number of subshell present in the main shell. This subsidiary orbits with the shell will be denoted as 0, 1, 2, 3 PF or SPDF. This tells the shape of the subshells. Okay, so principal quantum number is the main quantum number. There is no problem. Okay, yes, Lino, tell me what is the getting problem. So see, quantum numbers are nothing but the address of electron. Okay, where they are. Okay, so now if you want to learn about this quantum number, there are actually 4 type of quantum number. First one is principal quantum number. Okay, principal quantum number means nothing. It's the main shell, like KML, that one, 1, 2, 3, 4, as you can see in the picture, this 1, 2, 3. I don't have the pen tab with me. Okay, so please go through this one. If you have problem, up again you will be taught, don't worry. So there you shouldn't be any problem. This is basic knowledge, I will clear it for you. So this is the 1, 2, 3 or K element. This is the principal quantum number, or N means how many shells are there or orbits are there. This is the first one. Okay, this much hopefully you got. Next is azimuthal or angular quantum number. Angular quantum number is how they look like. Okay, this is the shape of subshells. It is denoted as SPDF. So in a single principal quantum number, there can be lots of different angular quantum number. Like we already know, in a single number there is 1, 2, 3, 4, lots of different things is possible. Okay, that is why what we are saying. Sorry. So next is magnetic quantum number. Magnetic quantum number, I am not going to read this through. Okay, don't worry about this thing. What is magnetic quantum number? Magnetic quantum number is a way where the how many different direction they have. Okay, an electron, due to its angular different motion, it can be different way. Basically, first remember that number n means the main orbit, then SPDF or angular momentum, they give you how they will look like, their shape. Then comes the magnetic quantum number. Not only how they look like, we need to know which direction they are. Okay, in x axis, y axis, z axis or xy axis, something like that, depending on which way. And lastly, the spin quantum number. Spin quantum number means in a single subshell there can be only 2 electrons. Okay, what are the 2 electrons? One is rotating +½ and another one is rotating -½, or one is right handed, left handed, or clockwise or anti-clockwise. Why they do this? Because if they do this, they will be stable. Means there is a theory about this, that whenever some charged particle is moving, it will create a magnetic force. So two electrons need to be moving exactly to each other opposite side, or else there will be a problem. They will not being typically told you, they will be actually repulsing each other. That is not right. They need to be very near to each other. Okay, they need to stabilize, they need to cancel each other out. Anyway, let's go to the next chapter or next point. This is C, this is the shape. Okay, so from here you can understand what I am talking about. So s orbital is a circle, so circle doesn't have a whenever whichever way you are looking at, circle doesn't have a direction. But p, this is a p has three types. So px, py and pz. P looks like dumbbell. If I go for the next slide, you can easily see how they look like s orbital. See, s orbital is a circle, and circle cannot have any things. Okay, circle cannot have any direction. That's why there is only one type of s. S is one time because it does not have any way to go, anywhere to go. It's a simple circle. Then comes the p orbital. P orbital, as you can see here, p looks like a double dumbbell. Okay, dumbbell, simply two smaller circles. This is d orbital, double dumbbell, and lastly this is f orbital. So there is, it's like a flower type of version. Okay, that's how they look like, and depending on which way they are, they can be like p can be 3, d can be 5, and lastly f can be 7 types. So this is called quantum number. Okay, so have you understood quantum number, or should I explain it again a little bit? Please tell me. It's basically where they are. Okay, okay. So many of you are still having some problem maybe to join the classes and everything. So I don't know if you can hear me or not. Okay, so if you know, have no problem, let us go for the next one. So this is quantum number. There is nothing about technical or tough about it. There are few rules about how the electrons will be arranged. Okay, how the electrons will be managed. So these rules are like there are different rules like Bohr principle, Pauli's exclusion principle. So these rules says how the electrons will be filling up what, the outside wall or outside one by one orbits, how they will be used up. That is the work, or that is the way the principles will work. Suddenly we cannot join anything, or suddenly we cannot put up any electrons to anywhere. There are special rule how these things will be filled up. So that is called Bohr principle. What is Bohr principle? Bohr principle is says that electrons will be filling up one by one depending on their energy level, increasing order of energy level. Okay, this is the main point you have to see. So first it will go 1s, 2s, 2p, 3s, 3p, 4s, 3d. That way it is going to go through, not the way we or you want to. That's not possible. All of you have seen this picture. This is called Pauli's okay, above principle. Above principle is where one electron will be filling up one by one. So it will be first go to 1s, 2s, then it will be your 2p, 3s. That way you have to arrange it. This is already you people know, there is nothing to worry about this way. Okay. Then is Pauli's exclusion principle. What is the exclusion principle? It is saying that according to this principle, no two electrons in an atom can have same set of 4 quantum number. So basically it is saying that two electrons can never have same address. Okay. So anywhere, anyway, there cannot be same atomic number, same quantum number for 4 of them. At least one will be different. Okay, at least the spin quantum number will be different. In a single home, you are sleeping and your parents, your friend or whatever, your siblings are sleeping. You cannot sleep in a single place. You have to sleep in a side by side. At least you cannot go for top of that. That is what it is saying. It's simply its address. Even in the same home, you will have a different name or different place to sleep. That is what this Pauli's exclusion theory says. And last is Hund's rule. What is Hund's rules? This rule deals with the filling of electron in the equal energy orbit of the same subshell. According to this rule, electron pairing in p, d and f orbit cannot occur until each orbit is given the subshell contains one electron for each or thus singly applied. So I don't have the picture here, if you know. So basically this one is saying that whenever electrons will be coming, so they will be filling up the positions one by one. That means first there is, let's say there is 5 Ds. So what will happen? One electron will be going inside each one of the Ds. Then only the next electron, when the 5 will be filled up, then they will come back and fill up the first one, the second one, the fourth one. This will go on. So first it need to be filled up one by one at a single electrons. Then it will again fill up one by one. This way it will go on. There is suddenly 2 electron will be in the 1D and another there is nothing. This will not happen. You have to first give 1 to each one, then you can fill up the other electrons one by one. So I don't know if you can understand because I don't have the picture right now with me. Let me check if I have it or not. Sorry, I don't have right now because I was not prepared for your class anyway today. So anyway, let's go for the next option. Okay, so there is some things you need to know. This is not given, but there will be some stability. This is a poor question that sometimes come, sometimes they don't come. So what is this? This is the stability issue or stability of half filled and complete filled orbit. So remember, these electrons or these atoms, they will be mostly full filled. They will not be full filled most of the time. They will be just depending on their atomic number, how many electrons are there, they will arrange. But when they have a full filled or half filled orbit, they are much more stable. A full filled electron orbit is like the Nobel gases. Nobel gases has the full filled orbit, so they are highly stable. You cannot use them for most of the reaction. They do not react. They are quite good. Nobel, that's in the name, because they are full filled the orbit. But if they are half filled even, still they go for stability. Like something there, like there is this copper has 29 electron, and the electron configuration should be something like this: 1s2, 2s2, 2p6, 2p. From the above principle we know 3p6, 4s2, but 3d9. See, D has 10 place for 10 electron. So suddenly it is not filling up the number 10, and the energy level is much higher. There is a big disturbance in the D for just only one electron. So what happens? One electron goes from S to D. So S become, there is only electron, and the D has 10 electron. This is a phenomena that says that half filled and full filled ones are much more stable. This is what we know of till now. That is what we know of. So this is called the half filled and full filled phenomena. So right now this type of questions sometimes come. One type of questions there you will find that they will give you some statements. Okay, statements are given something like which one is above principle, which one is Pauli's exclusion principle. This is a must know from your side. Okay, I will upload this one, you can go through. Hopefully there are some problems you will face, as I don't have any questions for this chapter only. Yes, I have some which we have not prepared. So I'll speak to Nilanjan sir, and he will give it to you, the whole question answer part of this one. If you have any question for today's class, at least I just ran through something, the quantum number only. I am not going to start a new topic. What is quantum number? Just know these are the address. Okay, in quantum number there is this 4-5 type of things that you can always count. That is principal quantum number, it is the main orbit, then azimuthal quantum number. Azimuthal quantum number means how they look like, the shape, and lastly the magnetic quantum number, and lastly end of the day the spin quantum number. Spinning quantum number means which way they are rotating, that's it. And magnetic quantum number is which way they are facing, that's it. Okay, means that direction. It's the quantum number. This is all about quantum number. There is nothing much of it. So if you go through at least once from your books or your notes, it will be quite easy for you. So tell me if you have any question from here, or I will finish the class here today. Because of this so lots of technical issue, I am not going to go through. So lots of students are having problem today joining class for this technical issue, mostly from our side. We'll give some extra classes, don't worry. There may be some upcoming 2-3 days, there will be some problems. We'll manage one by one, we'll take few extra classes. Okay, so don't worry. If you have any questions or any doubts during this, I will upload this one. This is I have made this before. These things are made for advanced classes, not for NEET. This is for JEE advanced level. Okay, I will give you the bare minimum of this portion. You may not understand all of the things, but I will cut down and I will upload this in the classes. And the lecture, if you want to go through, yes, I will see about that. Don't worry, let us find out the problem. Okay, if it is cleared out, we will go for the Google Classroom, as you are saying. No problem, we already spoke about that. If there is some problem we are facing, we will do it, don't worry about it. But let us first find out. See, there is a biggest problem with the Google Classroom. You may think, try to remember from last year, if there is no network, no one can help you. Okay, so it is Google or Zoom, doesn't matter. And last, the problem is here we can do few things, that is the recordings can be quite manipulated. We can upload it easily, you can find it. But if I do for the Google Room, we have to record, we have to upload in the drive, and then you have to download it. But here you can stream it these are the few problems we are trying to eliminate. Okay, we are new in the area of this technical, okay, so we are also facing some problems, and the connection issue is giving us a little bit hard time, which was quite resolved last 2 weeks, but as it's just updated at 9:30 in the morning, so there is little bit problem. By today we will finish clear up, and there will be some network issue for upcoming 2 days, so get ready for that. If it is too problematic, we will cancel the class. I'll upload this one right now. Check it. Okay, bye bye. I'm finishing the class.